Hey everyone, my name's Zach, and welcome back to another episode of Peeling Back Data. Today we'll be looking at scatter and line plots in R. So the first thing that you'll want to do is type library and then ggplot2. And then we need to load in the data set that we'll be looking at today, which will be cars. So we can click on that. So I'm going to briefly look at this. So this looks at the speed that cars are going and their stopping distance. So we can begin by going ggplot data equals cars, aesthetics, x equals the speed, and y is equal to the distance. That's our response variable. And then we can add a geom point to this. So this will create a nice basic scatter plot showing the relationship between stopping distance and speed. Now, the next thing that we can do to complicate this a little bit is to add a trend line. So we can do this a few ways, and one way is by going ggplot2 and then typing aesthetics. We just say the intercept of the line is equal to 0, and the slope, for example, maybe is equal to 1. So now we can see that we get a line going through the graph that we've just added on there, but it doesn't really reflect the data well, so we can experiment with the slope to see if we can get something that looks alright. So if we choose 3, that looks alright. We might want to change the intercept, but at the moment this is just showing how you can add these outlines onto the graph. Now another thing that you can do, which is nice, is you can change the color of this. So I might say change the color to be red. And then another important thing that you can do, which applies to all of the geom lines, is you can say line type equals 2, for example. Now there's different line types that you can choose from, shown by here. So you can have blank, solid, dashed, dotted, dot dash, long dash, or 2 dash. And you can just use this as a reference guide. So for example, we could put line type equals 6 right now, and we'd get that result. Now ggplot2 doesn't actually use any of the data, it's just something that we are pulling from our head, but if we want something that we know will fit the data nicely, we can use something called geom_smooth. So geom_smooth works by first typing in a formula. So in this case, we're going to say y is simply governed by x, and we're going to say the method equals a linear model, and that is all we'll say for the moment. So now we can see we get something like this with a simple equation of y equals x. Now we could change this if we wanted to be a polynomial, so we could say poly x2, and now I get a polynomial like that. Now you might have also noticed these bands around the line, so this is showing at the moment the 95% confidence interval. Now if you don't want this, you can say the standard error equals false, or if you do want it and you want to change the confidence interval, then you can say level equals, so the default is 0.95, or you could change that to say be a 90% confidence interval. So that's how you add a trend line to the graph. Now this is very nice, but something that you can do to help your viewer is to add in what the actual equation is. So to do this, we need to now load in another package called library ggpmisc. And then what we do is we specify our formula. So I'll just call this my formula equals y by poly x, 2 again. So using the same form as before, And now to this, we just need to add something called stat poly equation, and we're going to say formula equals my dot formula, and we'll replace the formula up here to be my dot formula because these two things need to be consistent. And then the next thing that we'll want to do is specify the aesthetics, and we're going to say label equals. Now this next part you just need to know, it's not really very intuitive. You say dot dot equation dot label dot dot comma dot dot r dot label, and the separation is going to equal, let's give it some spacing. And then the final thing that we need to specify on this is say pass equals true, and we can specify a size now for this text. So I'm going to choose 5, and we'll see how that looks. And finally, we can choose the color for the text. So I might choose blue. Alright, so we can see that turned out to be too big. So I can just simply alter that now. And now we get the formula for our polynomial, which is really nice. And we also see the r squared value. Now, the final thing that we can do to this graph is go into the labs and just add some capital letters to things to make things look a bit nicer, and specify that the y is actually the distance. We can go ahead and check the units for that. So we can look at cars, speed of cars, and the distance is taken to stop. And actually 20s, and the distance is in feet. So the next thing I'm going to show is how to add GMV line and GMH line to your graphs. So these add either horizontal lines or vertical lines to your graph. Now to show this off, I'm going to create some simulated data. So this thing I'm going to do is say sim equals data.frame. X is going to equal a sequence from 0 to 4, and we're going to say by equals 0.05. Now next thing I'm going to do is say sim $. The y is now going to equal just some random polynomial that I've created. So 3 sim, so we're taking the x value of that, I'm going to take 2 away from it, square it, plus 2, and we can add some random noise. So r norm, the number of observations, which we can see is 81, mean it's 0, and we'll make the standard deviation fairly small, so 0.1 will be fine. Now we can simply plot this data to see how it looks. So I'm going to say ggplot2 aesthetic x equals x, y is equal y, and then we add a gem point. So we can see we get this following polynomial. So now if we wanted to show where the maximum of this is, we could add a GMH line, and we just need to specify the y-intercept. So in this case, we know by construction that that will be roughly 2. And we can see that we get this nice horizontal line here. And again, we'll go ahead and change that line type to be 2, so it's dashed, and we might change the color to be red. We can also show whereabouts on the x this inflection point happens. So we can do this by typing GMV line x-intercept equals 2, and again we'll go ahead and type in the line type equals 2, and the color equals red. And then that plus above. And now we can see that we've nicely illustrated whereabouts the local maximum is for this line. can also see where that happens on the x-axis. So now let's look at geom jitter and geom violin. Now these are helpful when you want to see the trends for a continuous variable for categorical data. So to show this off, I'm going to look at the diamonds data set. So to do this, I'm going to type in data diamonds, and then I'm going to go ahead and create a little sample of this because it'll be easier to work with. So to do this, I'm going to type diamonds sample equals diamonds. Now we're going to create a sequence so we only select a certain number of the rows. So this way you specify the rows and the columns for that data frame. And we're going to select it to be 1 to 53,940, which is the number of observations in the data set. And we're going to choose I equal 10. So now we have this sample which is only 5,000 observations. So the next thing we're going to do is look at the relationship between price and cut. So to do this, we're going to say data equals diamond sample, and then we're going to go to aesthetics, x equals the cut and y equals the price, and we're also going to make the color equal the cut. And we're going to go ahead and add a geom point to begin with. So as we can see, it's actually quite hard to see what the trends are for the cuts in terms of price because there's just so many points and they all mold into one, especially for the cuts, very good, premium, and ideal. So to add some more readability and add some more information to the viewer, you can go ahead and add geom jitter. So what this will do is it will vary where the points lay on the x-axis so that they're spread apart and you can more clearly see what's going on. Now, geom violin acts in a different way, and this now helps you to see the distribution for each cut in terms of the price. So this is a really handy plot to have and to know how to implement. Now we're going to look at how geom point and geom line can be used together to form some really interesting graphs. So to do this, we're going to be looking at the dataset orange. Now the dataset orange looks at 5 different trees and looks at their age and their circumference. First thing we're going to do to look at this dataset is type in ggplot data equals orange, and then we're going to specify the aesthetics. So we're going to say x equals the age and y equals the circumference. And we're going to go ahead and add geom point. So now we see we get these nice trends, but it would be nice to see how these trends behaved for each individual tree. So now what we might want to do is say color equals tree. So now we can see what the trends are kind of nicely, but it'd be nice if we could connect these dots. We can do that by typing in geom line, and we get the following result. So this is really nice. Now I want to show you how you can modify geom point and geom line to make them look a bit different. So with geom point, we've actually got a few options here. So we can, of course, change the size of the points. But we can also change the shape. See how the shapes work. I've got a reference here, and we can see how each number responds to a different shape. So now if we go ahead and type, say, shape equals 14, we'll get this interesting shape of a triangle and a square, but we might want something that looks a bit nicer, so we can choose, say, shape equals 21, and we get those nice circles. You can also specify the fill, so you might want to make the fill equal blue, or you might want to choose something such as just black. And as we've discussed before, for gmline we can change the line type, so we can make that equal 2, and we can also change the size to make the lines thicker. So this graph looks pretty bad at the moment, so let's just make a few adjustments to make everything look a bit nicer. That looks alright. So you can see that some shapes don't have a fill, so you have to make sure that if you want to have a different fill color, you need to choose these shapes from 21 to 25. So I can go ahead and change that now to 21, so I can get my fill. Now it's also important to note that the order that you type in gm point and gm line matters. So if you want these points to appear above the line, what you simply need to go ahead and do is shift this around such that gm line is called before gm point. Get rid of that second plus. Now we can see that this actually looks quite a bit nicer, and the points are appearing above the line. Now we can also just add some nice labels as well. Just put some capital letters on things, so we can say X equals the age, and we can say Y equals the circumference. So I can see that's quite a nice graph. Finally, I'm going to show you how to do a bubble plot. So this is just an interesting use case of gm point. So for this, we're going to be looking at the dataset quakes, which looks at the locations of where earthquakes happened. And it gives it to you on a latitude and longitude basis. Again, we don't want to use the full dataset, so I'm going to say quakes sample is equal to quakes sequence from 1 to 1,000 by equals 100. So now we get this sample now, which only has 10 observations, and I'll show you how to do this bubble plot. To begin with, again, we're going to say data equals quake samples, and now we're going to specify the aesthetics. So we have the latitude and longitude. So we're going to say X equals the latitude, and then we're going to say Y equals the longitude. And now we're going to go ahead and add gm point. And we can run that. So now we see we get something very basic, just showing the latitude and longitude of where these earthquakes occurred. But if we wanted to add more information like we do in a bubble plot, what we actually want to say here is on the aesthetics for gm point, we want to say that the size is actually equal to the magnitude of the earthquake, and we can also specify that the color is equal to the magnitude as well. So now we get something nice like this, but the only problem is that we've got these two things on the legend. So to get rid of this, we can actually specify something called guides, and then we say color equals false. So what this says is that we don't want a color legend. So we get something like this. But it's probably more useful actually in this case if we got rid of the size, so we can have the color here on a nice spectrum. Now again, we'll want to add some nice labels to this, so we can say labs x is equal to the latitude, and we can say that the y is equal to the longitude. And we can also add a nice color scheme to this. So to do this, we can say scale color viridis B. So now we add this nice color scheme. And now since it's earthquakes, we might want to choose a sort of a red color scheme. So we can choose this option here, option B, and now we get this nice result. Finally, we can actually change the size of these points by using something called scale size continuous, and we just change the range here. So if we choose from 1 to 10, what you'll see is that the bubbles now get a bit larger. So it's a bit easier to see what's going on. And we can also, of course, make this much bigger, but things start to look a bit off and they're probably a bit too big. So we'll stick back to 10. So this bubble plot can be used in a lot of different situations. So can sometimes be used as a nice summary for, say, counts of people doing certain subjects or units, and you can just specify random x and y coordinates to spread out your bubbles. But it's just a nice, pretty way to display information. So that's going to end it for today's lesson. I hope you've gotten something out of it, and let me know in the comments anything that I can do to improve these videos. I recently made the mic quality a bit nicer by investing in a good mic, so I hope that's helped. Please like and subscribe for more videos to come, and I'll see you in the next video.